Everyone, welcome to your Algebra 1 play posit for the week, your first ever Thursday play posit. I'm excited. I hope that you guys find that this new day for play posits during the week is helpful, and then it gives you some more time in your schedule and the ability to maybe go through the material at a slower pace and hopefully helping you in the long run. So continue to keep giving me that feedback. And here we go. Make sure you grab your notes, have that play posit graded assignment open, and we'll get started. One quick reminder, I know that we talked about this in class on Tuesday, but I just wanted to continue to encourage you guys to do all the amazing things that you're already doing. I already have a few things written down, some snowballs, if you will, to turn into our lead teacher. And then next week, we'll have an update for you on how many snowballs the whole school earned this week. And we need to earn we need to earn 250 or more snowballs to earn that snow day, that virtual snow day. So I know that with the Verizon outage on Tuesday, some of us were able to make it through class, some of us watched the recording, and we were kind of just all in a few different places than usual. So I wanted to start here and go through these examples from last class. So this is solving using substitution, and I have some steps here that we can follow. Remember, you don't have to follow the steps. I'm sure once you guys do this enough times, you're going to start to sort of have your own process. By the way, this is an example of an algorithm when you put steps into place to get from the beginning to some solution. So that's pretty cool how you can show different algorithms in life and in math class. So step one, solve one of the equations for a variable. So we can label these like equation 1 and equation 2. And it's totally up to you. You guys, you can choose equation number 1 to solve for x or y, or you can choose equation number 2. It's my opinion that we should try to choose like the easier one, the one that has less stuff going on. And I feel like equation 2 is that because the only coefficients we have in front of these variables is a 1. So there's just less going on here. So I'm going to choose equation number 2, and we're going to solve for either x or y. Again, it's totally up to you. I'm going to solve for x because, again, I just feel like that's the easiest thing to do. If we were going to solve for y, we'd have to get rid of this negative, which you totally could. But let's go the easy route. So we got x by itself, x equals y plus 13. And that's it. We did step 1. We got one of those variables by itself. Step 2, plug that into the other equation. So instead of x, we're going to plug in y plus 13 into the other equation. I do want another color. Here we go. So step 2, instead of x, we're going to write y plus 13 plus 2y equals 10. All right, step 2 is done. Step 3, solve for the variable. So now look, we only have one variable, so we can solve for y. Our goal is to get y by itself. But before we can get y by itself, we kind of have to do all this math, right? You think of PEMDAS or GEMDAS, right? So we have 4 in front of the parentheses. That means we're going to distribute 4 times y and 4 times 13. Whoa, we're getting to be some big numbers here. I'm going to grab my calculator just to make sure. I think it's 52 because I did 4 times 10 is 40 and 4 times 3 is 12 and 40 times 12 is 52. Let me just make sure. Yep, 52. Okay. Next, on the left-hand side, we need to combine like terms. 4y plus 2y is 6y. I'm getting closer. We're going to get this term all by itself, so we'll subtract 52 from both sides. And lastly, this is 6 times y, so we're going to divide both sides by 6. And you get -7. So remember, the whole goal, we should probably talk about that. The goal is to figure out where do these lines intersect. At what x and y value are they the same? So we found it. We found the y value. So we did step 3, we solved for y. Step 4 says plug that into either equation to get x. So remember, we're trying to get an x and a y coordinate. We have the y coordinate, it's -7. Now we can take the y value and plug it in anywhere. We can put it in here and solve for x. We can put it in here and solve for x. We can put it in here and solve for x. I kind of feel like we should put it in there. It seems like the easiest way because x is already by itself. So x equals -7 plus 13. But just a reminder, anywhere you put that y, you're going to get the same x value out. That's the whole point of a system, to be able to show where they're equal at the same time. And this is 6. X is 6. There we go. We found our solution. That's a coordinate point. Sometimes the problems will just want the x value, and sometimes they'll want the coordinate point, the x and the y. We typically show it as an XY point because we do look at these graphically to show where they cross. Now the cool thing about all of these, which I'm going to show at least once today, is that you can double check your work by graphing them in Desmos. You can literally just put both of these in Desmos as you see them, and then where those lines cross will be the solution. So let's do another one. Don't forget, at any time you guys can pause the recording and try them on your own. Step number 1, solve one of the equations for a variable. So now again, it's up to you. You can pick any one you want. I don't know. I'm kind of leaning towards equation number 2 for some reason because there's a 0. Okay, let's pick that. Okay, so we got to pick. I'm just going to get x by itself. Why not? They're both kind of the same with the 6's there. So we have 6x equals -6y. All right, so we have 6x equals -6y. Let me grab my pen. Okay, now we're going to keep solving for x. We'll divide both sides by 6. And we get x equals -1y. All right, step number 1, done. Step number 2 says to plug that into the other equation. So we solve for x. So instead of x in the first equation, I'm going to put what I got for x. So step number 2, -7, and instead of x, I'm going to put -y. Here we go. Step number 3, solve for the variable. So we're going to get y by itself. So a -7 times a -y is a 7y. And then we can combine like terms. So we have 9y equals 18. And divide by 9 is 2. Cool, so we have half of our solution. Remember our solution, we're going to get that coordinate point where they cross. So our y value is 2. Step 3 is done. Step 4 says now, okay, you found y, plug that into another equation to get whatever x is. So we can plug it in anywhere we want. It will give us the same value. So let's just put it, I personally feel like it's easiest just to put it here again because x is already by itself. So instead of y, we're going to put 2. X is -2. Ta-da! So let me show you guys this one on the graphing calculator. Again, all you have to do is plug in the equations as they're given. So let's pull up Desmos. I have them already in here. And you can see it plots it for you, and you can click on that dot in between and it will tell you where they intersect. Sure enough, that's the value that we got, the values that we got. And this means that that point, -2, 2, will satisfy both equations. If you were to take x equals -2 and plug it into both of these, it would work. You would get 2 out for y. It's basically like a simultaneous solution. It works for both. That's the whole point. So cool, we did step number 4. Okay, let's try another one. Hopefully you're kind of getting the hang of it now, right? We're going to pick one of the equations to solve for a variable. Equation number 1 or equation number 2? I'm leaning towards equation number 1. I don't know about you. The x is already kind of by itself, so let's pick number 1, and I'm going to solve for x. So we'll just move over the 7y term by doing the opposite, and x equals negative 7y. Step 1 is done. We're going to take that and plug it into the other equation. So put that in for x. Whoops, the other equation. So here's step 2. 2 times negative 7y minus 8 equals 22. Step 2 is done. Step 3, go ahead and solve this. We have one variable, so we can get it by itself. So 2 times negative 7 is negative 14y. And we can combine like terms. Negative 14 minus 8 is a negative 22y. Ooh, this looks nice, right? Divide both sides by negative 22. And y equals negative 1. All right, we have half of our puzzle. We need to do step 4 now. We need to plug that into either equation to get the other variable. So I'm going to plug it in here. Again, I just think it's the easiest. So x equals negative 7 times negative 1. X equals 7. Just to kind of show you at this point that you could plug it in anywhere, let's plug it into equation number 2. 2x minus 8 times negative 1. And let's solve for x. We better get 7 or else we did something wrong. So negative 8 times negative 1 is a positive 8. Right now we'll keep solving for x. We'll subtract 8 from both sides. So I'm going to go over here. You get 2x equals 14. And then we'll divide both sides by 2. And look, x is 7, just like we said it was. So it does not matter where you plug in that negative 1 because of the whole point of what a system is. It's got to work everywhere. Just like our other ones, if you were to put these two equations into Desmos, the point where those lines intersect should be and will be 7, negative 1. All right, that was sort of the finishing up of the algebraic method number 1. Now I wanted to show you guys the algebraic method number 2. And I know this is kind of a fancy word maybe to you guys. I mean, we're in algebra, so this is kind of like part of the culmination of what we're doing in this class, but it just means sort of by hand, doing the math, doing the work versus seeing it visually or graphically. So this is called the combination elimination method. So the goal is to combine both of the equations and being able to eliminate one of those variables so you can solve for the other. So as you're looking at these 4 examples, take a look and see, what do you notice? What do you notice that they might have in common? These words, combination and elimination, how might they come into play with these 4 examples? And I'll give you a minute to kind of look to see what kind of patterns you might see in these 4 different problems. And we're going to be able to solve all of these. And if you look, example 1, check out the coefficients of the x term, the numbers in front of the x term. They're the same, except one's negative and one's positive. Check out number 2. We have a similar situation. Number 3, look at the y's. They have the same coefficient. One's positive, one's negative. Here with the x's. This is what we're looking for in the combination elimination method. We're looking for one set of variables to essentially match with opposite signs. So we're not talking about reciprocals. These are not reciprocals. They are opposites. So -4 is the opposite of 4. 6 is the opposite of -6. And the reason we want that is so we can go ahead and combine them and eliminate them. So let's do an example. Again, I have the steps for you. Step number 1, line up the variables in the equation. So you want to be able to see, do I have any pairs of variables that have that opposite? So the x's are right on top of each other, the y's are on top of each other, and the constant values are over here on the right. So you want everything to be in the same line. So step number 1 for us for this problem is done. Step number 2, choose the easiest variable to eliminate. So if you look at this problem, what do you think the easiest variable to eliminate would be? Hopefully you're screaming at the screen, not really screaming, but it's the x value, right? Because again, those coefficients are opposites of each other. They're both 4 and this one is negative. So we're going to choose the x variable. Step number 2 is done. Step number 3, ask yourself, do you need to multiply by something to make them match? But have opposite signs. In this case, they're already opposites, so we're good. We don't need to do anything to the problem. We're going to see ones later where we're going to have to change them. We're going to have to multiply by something to make them match or have opposite signs. But we're good. These are ready to go. They're already opposites. So let's do it. Let's do step 4. Let's combine the equations by adding vertically. So it's like good old-fashioned addition. Right up and down. -4 plus 4, that is eliminated. And again, that's the whole point, to be able to eliminate a variable so we can solve for the missing variable. So that's step 5, solve for the variable. So let's go ahead. -2y plus 8y is 6y. -12 minus 24 is -36. Now we're on step 5, right? Solve for the variable. Let's keep solving for y. Divide both sides by 6. -6. Y equals -6. Look at that. We already found the y value. We just need x. So step 6 says once you have one variable, plug it into any equation to get the other one. That seems pretty easy. So we can put it in anywhere we want. I'll put it here. Why not? So -4x minus 2, instead of y, I'll put -6. And we can solve for x. -2 times -6 is a positive 12. Keep solving for x minus 12 from both sides. -4x equals -24. And divide by -4. And you get a positive 6. So we'll put a 6 here. That's the solution. That's it. And the reason this works, again, is because we're solving them simultaneously, which means at the same time. And that's the whole sort of definition of a solution to a system. It's where it's happening at the same time, at the same point, where they cross. So this is just another method. Could you have used the substitution method on this problem? Totally. You could have picked one of these equations and done these steps. Solve one equation for the variable, plug it into the other, and all of that. Totally, 100%. We just have multiple methods to get to the same answer, which I love. So hopefully you'll get to pick your favorite method. A lot of people, their favorite method is graphing. It's very visual. Okay, let's try another one. Step number 1, let's line up the variables. Look, these are all out of whack. So I'm going to put the x terms first. Line them up. Get in line, guys. There, I didn't change any of the values. I just rearranged them. I put the -4x in front and the 2y in back. totally fine. Step number 2, choose the easiest variable to eliminate. So what do you guys think? Which one can we just automatically get rid of if we were to add them? And that is the x variable. So we're going to get rid of the x. Do we need to multiply by something to make them match? Nope, they already match. They're already opposite signs, so we're good to go. So we're just going to go ahead and add up and down. Those go away. That's the whole point. And you get negative 10, right? And then we'll divide both sides by 10. Y equals negative 1. There we go. There's our y value. And to get our x, look, we just did step 3, 4, and 5. Once you have one of the variables, in this case we found y, just take it and plug it in anywhere else. How about there? 2 times negative 1 minus 4x equals negative 30. Let's solve for x. All right, we're going to add 2 to both sides. Negative 28. Excuse me. Negative, right? Yep. Divide both sides by negative 4. And you get x equals 7. There's our other solution with that point, 7 comma negative 1. You can always confirm by graphing. Done. Okay, let's do one more. We're going to line up the variables in the equation. They're already lined up. The x's are with the x's and the y's are with the y's. Done. Step number 2, choose the easiest variable to eliminate. So when you look at this one, that's kind of up for discussion, right? Because right now, as it stands, none of them are opposites of each other yet, right? This is a 4, this is a 1, this is a 9, this is a 3, negative 3. So none of them are opposites. So let's move to step 3 and see, do we need to multiply by something to make them opposites? The answer here is yes. So it's kind of up to you guys. We can pick. If we want to make the x's opposites, what would we need to multiply x by? 4, right? Because this is a negative 4 and we need this to be a 4. And it's already a 1. What if we wanted the y's to be opposite? What would we need to multiply this by to make it a 9, right? Because we want it to be an opposite 9. And we'd have to multiply by 3. Let's do that. So to make something an opposite, we're going to multiply everything by 3. And this is allowed as long as you're doing it to everything. So you're basically just changing everything to a multiple of 3. So I'm going to rewrite the first equation. And now we're going to multiply everything in the second equation by 3. And the goal for that is to now, look, now we have a pair of numbers that are opposites of each other. The y term, we can now very easily eliminate. We can combine and eliminate. So let's do that. Negative 4x plus 3x is negative 1x equals negative 9. Divide by negative 1 and you get x equals 9. You could have totally chosen to multiply the second equation by 4 and eliminated the 4's. You'll get the same answer eventually. So it's up to you. So now we have the x value. We can plug that in anywhere, literally, in any one of these and get the y. So I'm going to put it back here in the original. 9 minus 3y equals negative 6. Subtract 9 from both sides. Negative 15. We'll divide both sides by negative 3. Y equals 5. There's the answer. Done, done, done. So you can see this one was an example where they were not automatically opposites of each other. We had to multiply by some constant value to change the way it looked. We didn't change the values per se, because remember, we did it equally. We multiplied everything by 3. And again, we could have chosen to multiply everything by 4 and eliminated the x's. It's up to you. What method do you think is easier? So now we have 3 methods in our pocket. We have graphing, we have substitution. So we did mostly last class, right? That's where you get it to be x equals or y equals something. And then today we did combination elimination. Combine and eliminate. I have a favorite. I also have one I think is the easiest, and I'm sure you do too. And I know we just learned combination and elimination today. So obviously you might not be super comfortable with that yet. It's going to take a little bit of time and some practice. But you guys, I feel like it is a super valuable process. So I truly hope and ask that you take it to heart and that you try it by hand. I know when you see this graphing and you guys know you have that Desmos calculator, it's there for you. And I know you're going to use it. I mean, so would I. I mean, I use it as a teacher also, to confirm our work. But I'm kind of slightly begging you to also learn the algebraic way because it's just a really valuable process. Going through these steps, like I said, it translates to life. You guys go through algorithms all the time and you don't even realize it. The steps to get ready for school. I have to wake up. I have to take the blanket off of me. I have to brush my teeth. I have to use the restroom. I have to eat breakfast. Those are all algorithms. Those are all mathematical processes. And learning how to solve a problem from start to finish, whether it's a solution to a system or changing the tire on your car or a complicated financial problem in your job or a marketing solution or, I mean, I could go on, right? Or let's say you're trying to build a new table for your house. Like any kind of problem involves a mathematical algorithmic solution. So we are learning tools for life here. And I'll get off my soapbox now. Good thing we're not in live class because you'd be chatting me like, okay, okay. So when you look at this first one, we can kind of talk about some things. What do you think is the easiest method for number 1? Now we might just go straight to graphing. I get that. But also, if you look at this first one, I kind of think substitution might be good. Because anytime you have a term where the coefficient is 1, it's pretty easy to get it by itself, right? Some might argue that this one should be easy for combination and elimination. Because you could just multiply the entire first equation by -7. And then look, these would be opposites of each other. Or I'm sorry, +7. Those would be opposites of each other. And then you could eliminate. If you look at number 2 here, I mean, you could do substitution, right? We could get the x by itself. It'd be a little bit longer because we do have a negative, so we'd have to get rid of that. Right? Remember, substitution is when you get one of them by themselves and then substitute it into the other. Or you could do combination elimination. We can multiply the top by -4, and that would make this a +4, which we could very easily then eliminate. I think that's fun. So you can see there's a variety of ways to solve these problems. And I hope that you learn and practice and process all 3 ways and that you certainly reach out for help. We'll keep doing more of this and you guys still have some lessons in your OMHS on this. I believe we are still ahead, which is great. I love being ahead of the lessons in the OMHS. It might not always stay that way because we'll have holidays and testing days and this and that, but we're gonna attempt to stay ahead or on track of where your OMH lessons are. Hey, look, I'm under 30 minutes. You guys have a great day, have a great weekend, and I'll see you next week. Bye, everybody.